Hello, I'm Dave Sexton. This is my third video in my series of videos on reactive programming. And in this video, we are going to implement a compositional query. So we're going to actually get into composition here, I believe. And I want to start off by first addressing the question I left you with in the previous video. I thought about it a little bit after that, and I realized it was just a really bad question, I think. It was a bad challenge. I mean, the only real solution that makes sense is probably just the same as the one for the usernames. Using a tuple doesn't really make sense here because a URI is already a reference type and it could be null. So a tuple doesn't really add any value. So anyway, I'm sorry about that. It might have been worth doing it anyway, just as an exercise, because this is a fairly common pattern to use, so why not learn the pattern? But it wasn't really much of a challenge because you could really just copy this code. So I think we're just going to delete this for now, and I'll just implement the service URL validation the same way we did with user validation. So we'll do the same thing again. We need a connectable observable, valid, we'll just call it like service URLs. And this will be a string, right? Because we have to validate them. So now it's going to be service URLs equals, we'll say from URL in input dot URLs, service URLs, right? Select, how do we do this? URI, try create. Oh, right. So this is an output parameter. Okay. So this is fairly common. You'll run into try create as a fairly common pattern. It has an output parameter. Unfortunately, query comprehension syntax doesn't support output parameters, and even the new C# feature that allows you to use like inline declarations, which I really love, inline definitions or whatever it's called, of variables, it doesn't work inside of a query, which I hope they fix at some point because I think that would be extremely useful for situations just like this. Anyway, we're gonna have to do something about that. I think probably the best way to do that would be to just create a separate factory method for it. So anyway, it doesn't really matter too much, but essentially we want a URI from a string. Oh, service URLs is a URI. That was actually a mistake, I think. Yeah, so a URI is already validated. That's how you get a URI. The URI class is constructed. It has to be constructed in a valid way. If it's invalid, you can't even construct an instance of it. So this was supposed to be a string. This is actually supposed to represent raw input data, right? So you type your URL into a text box, and then it gets passed or pushed into the business layer for validation. So it should be a string, actually. That was a mistake. Sorry about that. So now we have a string, and we can pass it to try create, which actually requires a string as input. And now we'll implement this. It's actually URI, right? URI. URL. I think it's always going to be absolute. Yeah, will always be absolute URI. So if it's valid, it's a URI. Otherwise, it's null. So we're going to convert that Boolean output parameter to a null if it's false. So now we have a null value for an invalid URI and an actual instance, a valid reference if it's a valid URI. I'm just going to move this method, though, down here just to get it out of the way because we don't have to look at it. Okay, so now we have our URI. This is a string. This is a URI. So this should be an observable of URI. Oh, extra parens. That's why. Because we're going to have to publish it, right? So again, a side effect. We want to share the side effect across multiple subscriptions. You publish. So service URLs is an iConnectable observable of string, which is actually not a string. It's a URI because it's a URI if it's valid and it's a null if it's invalid, right? So now we could have our valid service URLs as a query written in terms of the service URLs which have been validated. So that's from URL in service URLs, where URL does not equal null, select the URL. Actually, that's the same query as the valid usernames. So no surprises there. And then we have invalid service URLs is an output property, and that's going to be from URL in service URLs, where URL equals null. Select is probably unit, unit.default. And that's the same as the invalid usernames query. So the point of this is that we're taking this service URL, this input service URL is an observable string. We're performing the validation only once and sharing the results with multiple subscriptions, and then splitting this observable into two subscriptions, one for valid service URLs and one for invalid service URLs. It's the same exact pattern as we did here for usernames, right? And you know what? Before we move on, I'm just going to organize this a little bit. I think I'd like to have the definitions for the fields, grouped together, and the definitions for these output properties grouped together, and these local variables, which we're going to have to build a composed query over, will be together as well. It might be a little easier to maintain like this. And of course, if this gets really out of hand with lots and lots of queries and details here, we could use object-oriented programming to our advantage, right? And maybe group them by some cohesive name and put them in a type somewhere else, or even just in a separate method. And we might not have to go as far as types here. Again, we want to try to not be stateful. So this state here is necessary because we want to defer connection until later. Which reminds me, we are going to have to actually connect the service URL connectable observable, just like we did with users. And here's our first composition requirement. So when you're composing queries together, quite often, you can imagine that every sub-query or every observable will have to be subscribed to at some point, and that's going to return to disposable, which represents the subscription. You dispose it disposes of the subscription. So there are many subscriptions floating around, many disposables floating around, and you need some ways of composing the disposables themselves. You want to be able to have like a group of disposables that could be disposed, that implements disposable, so that when it's disposed, it disposes of the entire group. You might want other patterns and behaviors as well. So RX has a library of disposable types built in that allow for composing over disposables, because it's such a key part of the reactive programming mechanism that RX implements, right? iDisposable represents a subscription, and the disposable library allows us to very easily compose disposables or subscriptions. So in our case, we're going to want to use the stable composite disposable. So I'll just type that in, stable composite, right? And that has a factory method called create. Yes. So this will pass in users, and what was the other one? Service URLs. Yeah, connect. There you go. So we've deferred connection. That's why publishing allows us to take a cold observable, which has subscription side effects, or in this case, computation side effects, and share them across multiple subscriptions. But at some point, you have to connect to the underlying observable. So connection defers the underlying call to subscribe, and we're putting that in a field here only for not because we want to be stateful regarding data in the query or anything like that. It's because we just want to have connection deferred until an imperative call to the connect method on our type. So the consumer of our type will create an instance of the reactive program, but it won't cause any side effects. It will just build all the queries, no side effects, and then when it's ready to connect, it will call connect. This also allows it to call disconnect by disabling, by calling dispose on the iDisposable at any time. And it doesn't need to keep track of how many observers or subscriptions it has on all these other observables. They're all composed into one single nice iDisposable interface, which is a common interface in C# anyway. So this is a really nice pattern, I think, to be able to defer all of your published observables, the connection to the underlying subscriptions of those observables, to some method that can be called imperatively. And this is like the outside. This is the edge of our program here. Our whole application is going to be built sort of inside, or most of it anyway, as much as we can, inside the reactive program, which is the name of this type. And the connect method is just the edge of that, right? So it's like the startup process of our application is going to be responsible for connecting and disconnecting at some point also, perhaps under certain circumstances, right? Perhaps in our case, the only time we'll actually disconnect is when the app closes, but when it shuts down, disconnection is going to happen implicitly anyway. But it's nice to have this pattern here explicitly. It's a common pattern anyway. There are times where it actually does make sense to be able to disconnect the entire program or sub aspects of the program. We could split them into different kinds of connect methods based on their semantics. But anyway, you get the idea. Now, we're not being totally reactive by using this mechanism, but it just ends up being sort of a necessity because of the world we're in, where it's like object-oriented and reactive and functional. It's like a hybrid. So this makes it really useful. It makes reactive programming very useful inside an object-oriented world. Okay, so we're gonna stick with this for now. And what's the next thing we want to do? We actually want to get back to the spec, I think, at this point, right? Because now we want to compose. So we've composed disposables, but now we want to compose observables into higher order observable that can be used for additional processing and perhaps even be used to compose other observables and so on. So let's look at the spec where we left off, which is what I'm going to do. I'm going to actually make this horizontal. I want to try this out. So actually this is pretty good, yeah, because if I keep this like this, then we don't have to see much of this at one time. Okay, let's go with this for now. So the rule here, when the connect button is pressed and the username is valid and the service URL is a valid URI, we want to do this other stuff. We want to react to it. So this is like a little subquery. And this is a business rule. So the goal here is to write a query that reads very much like the spec, right? Now you're not going to be able to get it exact one for one. There's many different ways, although there's many different ways to write it in English or your native language, and there's many different, likewise in RX, there's many different ways to implement it. So I'll be showing you, I probably have said this already, but I'll be showing you implementations that just make sense to me. There might be ones that are better. There might be ones that not only are more succinct, simpler, easier to maintain, but also might perform better or have better memory profile. But we'll get to that in the future, right? We could always refactor, we could always improve the code as we go through, but we want to, the goal is to just make it so that the code reads similar to the spec, okay? So that way the app's maintainable. And there will be multiple ways to do that. I'm just going to choose the approach that makes the most sense to me at the moment. I'll probably make a mistake and have to go back and fix it anyway, because it's, it's pretty common when you're dealing with this kind of stuff that you'll notice a slightly better way to do it after or something, and or there's an operator I forgot, I could use that, and it does. I just built out this whole thing that's 3 or 4 operators long when I could have just used one operator. So that kind of stuff happens. It just requires experience. You practice using RX. You make sure you pay attention to the operators that exist in the library and try to remember them every time you're trying to solve a problem, and maybe go through the list and just say, was this operator appropriate? Is this one appropriate? You'll notice some interesting ways to solve problems that maybe you hadn't thought of before, and that could change the way you solve problems moving forward from that point on. You learn about operators that are a bit esoteric, and you realize, wow, they're esoteric, but they're really, really powerful, and maybe I'll be using them more often. So there's multiple ways to solve problems. But the only way to really move forward is to learn what operators are available and practice using them. Okay, so this is not a video about me teaching you all the individual operators and how to use them. There's plenty of information around about that, and really you have to spend your own time doing it. This is really a video about how to think about reactive programming and solve reactive programming problems in a way that I feel is the most useful, which is to say we want to respect declarative programming, functional aspects of it. We don't want to keep state externally. We want to try to keep everything in the query, and we want the queries to be declarative and read like the spec, and that's the goal here. And actually mentioning state is important because we're at a position now where we kind of have to deal with state for the first time, right? We have this concept of a username is valid as part of our sort of trigger here. So if the connect button is pressed, we have to know the username is valid. Well, where's the username come from? So your intuition as a, say, non-reactive programmer is probably to have some field somewhere, right? You might say, okay, well, let's have a user field like this, right? And this will be like last valid user or something like that. And that way we could check it. In the click event handler, you check is the last valid user null, but it's very explicit. And you're not being declarative in that sense. It's not reading like the spec. In order to understand what's happening, I have to first know that there's a field somewhere called last valid username. Then I have to find your event handler and then see how the event handler uses an if block to check if this is null, right? It's not the declarative approach that we're looking for. Something very succinct, a couple lines of code, and that's it. So this is the wrong approach, at least from the reactive programming perspective. We want to stay more functional rather than object-oriented. Objects have state. We don't want to explicitly define our state, right? So we're not going to do that. Instead, what I'm going to do is something a little different. So the way I look at this query is that the username is valid. Well, we know, so again, we want to think in terms of input and output. So the username is valid if valid usernames pushes it in, because that's what this observable represents. And it now hides the details of what it means to be a valid username, or how to get a valid username. That's this query right here. And this query is also an abstraction. It's not how to do a where or filter. In other platforms, it's probably called filter, the operator that you would use here, and select would be map, for example. But it's not about how to filter or how to map. It's about merely the fact that that's what you want to happen. How it works is hidden from us, right, by these operators, which is really nice. So this is the declarative approach. And you can see how we could compose. We're going to take valid usernames and can compose that with other observables like valid service URLs and click, or I think we have a connects observable for clicking the connect button, and we're going to compose them together to create another query. So it's taking subqueries and creating higher level or higher order abstractions by creating new observables in terms of those other observables. And we could just keep building up until we have the output we want. At some point, we hit the edge of the reactive world where we get to the output, and now we want side effects to occur. And we could subscribe to the observable and then cause some side effects. And that's maybe a somewhat oversimplistic way of describing it, because you'll notice that while we're doing this, side effects are sometimes useful in the middle of queries, and we're going to have to call that out when that's useful. It's not like that you always want to avoid it. It's that you want to make sure it's explicit. So it's not just about input and output and streaming and asynchrony and declarative programming. It's also about managing side effects. So we're going to get to all that stuff at some point, I'm sure. So for now, we want to deal with the fact that we have some state somewhere. Where is it? I don't know yet. We'll figure that in a moment. And we want to compose. We know it's going to come from this, but we're going to have to keep track of the latest one, right? The last valid username. And we're going to want to compose that with this concept of a connect button being pressed, right? So let's just find the input for that first. Down here, we have an observable of unit, which represents connects. I think this was the thing that represents the connect button being pressed. It doesn't have to be a button, right? We don't care. We're very abstract in this business layer, which is good. But we could think of it as a button if it makes it easier for us to visualize that mechanism. So you click a button, it raises an event. We're just converting that into an observable, which pushes a unit in every time the button's clicked, something like that. So that's our connects observable. So we can grab that here. I'll just make it a local, just maybe so it's in scope. What is it? Is it input? Input connects, yeah. So now we have three things in scope, the three things we need in order to implement this business rule. But we want to write this. We want to write code, a query that kind of looks like the business rule, right? That's the goal. So again, what I started out saying at the beginning was that there's different ways to write a query, and often, and it's the same thing as it's language, right? So there's different ways to write this sentence. So just because a sentence is written in this exact way doesn't necessarily mean it's going to be the best way to write it as a query. So it's not going to be one for one, not necessarily. Sometimes, most of the time, it's probably not, but you want to get something close. That's the goal. Now, the reason why I'm mentioning it is because when the connect button is pressed is the first thing written here, but that might imply that you want to subscribe to the connects first, right? So your intuition might be to call subscribe in this. It's not what you want to do, right? You don't want to subscribe to observables. If you notice, the word subscribe here doesn't exist at all in this file. This is the first time I wrote it. We're not, with all these observables and everything we've done so far, we haven't actually called subscribe at all, because the goal isn't to call subscribe. That's essentially breaking out of the reactive approach and doing something, executing an observable function that reacts to observable input for its side effects, right? So in this case, we would do something imperative because the connect occurred. But we don't want to do something imperative. We want to remain reactive. So in this case, what you really want is something like sequential composition. You would say from connect, or in this case, it's a unit. We could use an underscore just to represent that we don't care what the payload is in the observable. The notification, for us, it's about the time of the occurrence. It's important, not the data it contains. So underscore just says we don't care about what that is. It's actually it's not a special character in this context in C#. It's just a sort of pattern I picked up from somebody else. I don't remember who, and I like it. It's just a nice, clean way of doing it, I think. So anyway, we're going to say from underscore in connects. So from notification in connects, when the connect observable pushes in a notification, then we want to do something. And using a SelectMany operation here could be potentially useful. This would be your intuition, right? Reading the query, when the connect button is pressed, then do something else sequentially. Then do something else sequentially, which is these things down here. But what's interesting is that we will have to get to that at some point. But it's sort of like the filtering logic that's important to us now, because we want to be able to say when the connect button is pressed and the username is valid. Well, what if the connect button is pressed but the username's not valid? So filtering is something we've done before a couple of times. So your intuition might be to say, let's use a where clause. The problem with the where clause here is that we don't have the state captured yet, right? The concept of a valid username being the last valid username that was pushed in, we don't have that concept anywhere, right? So we can't just do this if your intuition was to say from, in this case we would want it like from username from username in valid usernames, which tells us that, a valid username just came in. The problem with this approach is that it's not the latest username. It's what would end up happening here in this SelectMany query is that multiple from clauses compile to a SelectMany, if that's not clear. And for those of you that aren't using C# as your primary language, and you're using another, like let's say not even RX.net, but Java, RxJava, or JavaScript or something, I believe SelectMany is called flatMap. But anyway, the point is that this compiles into a SelectMany query, but sequentially it will say, when the connect button is clicked, then await, the next valid username that arrives. But that's not what we want, right? We want to be able to say when the connect button is pressed, check the last known username. We need the state somewhere. The state has to be available to the connect query when it happens. So in a sense, we want this reversed. Now this might be kind of surprising, but it's fairly common actually. What we're doing is we're taking something that's essentially a point event, right? Observables are point events. In reactive programming and reactive extensions specifically, its implementation of it, it's dealing with point events. An event that has no time associated with it, no duration associated with it. The event comes in, you do something with it. The next event comes in, you do something with it. But the concept of the event, if you will, or the notification, the push-based notification, is just a single point in time, right? Functional reactive programming, however, is on the other hand, deals with continuous functions. It's not point events. It's a continuous stream of data where any point in time is a valid point in time with a valid piece of data. That's not true in RX, right? In RX or reactive programming in this manner, we're dealing with point events, notifications that get pushed to us. There's no in-between event that would make any sense. You can't say, what about the valid username between the first valid username and the second valid username? That doesn't make any sense. So it's not a continuous stream. However, it's quite often useful to attach a duration to a point event. And what SelectMany does is it essentially attaches, it's one of several ways of doing this. This is probably a bit esoteric to describe it this way, but I like to think of it this way. I don't know that I've ever seen anybody else describe it this way, so I don't know how useful it's going to be. But the way I like to look at it is that the SelectMany operator, because it's a projection, actually, I could probably explain this a little bit more clearly if I show you the signature. So it would be like valid usernames.selectMany. This is the fluid method call syntax rather than the query comprehension syntax way of doing it. But this two consecutive from clauses will compile into this call to SelectMany anyway, where we could pass a lambda in. So it'd be like valid username goes to. And the signature for this is actually an iObservable. That's not the right signature. It's this one. So a function that takes in a user, the username, and we're using a lambda expression to implement this function, takes in a username, and it's not username anymore. It's actually just valid users. Sorry, going on so many tangents here. Hopefully I'll make this a little bit clearer at some point. Usernames is fine for invalid. Okay, so this is valid users technically, and we could just call this user. I just want to be clear, right? Okay, so there we go. So a user comes in. When the user arrives, we project it into an observable. That's the same thing as attaching a duration. Durations in RX are represented as observables. So it's essentially a projection of a point event, some data, some notification, into an observable. And often you end up producing an observable of observables. So like it's this like nested observable. So you have this outer observable, which then pushes observables as its notification type, data type. And those inner observables are windows of data. They represent a duration from some point event. That's often the way it is. Now, there's various operators we're not going to get into that are related to that shape of data, nested observables, and they're very important. And there's other actual contracts around that as well, how to deal with it. But the essence of it is that you're just taking a point event and adding a duration to it, like that the concept of that event being projected to an observable is the same as like saying taking an individual point of time and the state associated with it and making that state live much longer than just that individual point of time, and asynchronously, I might add, because you're dealing with another observable, and as I've said previously, multiple observables represents the potential for concurrency in Rx. So as soon as you add a duration, you're now dealing with potential overlap, right? Which you don't get in Rx's because of its serialization contract. So you could get overlap by attaching a duration to a point event. SelectMany allows us to essentially do that because it's the sequential composition operator. It's composing an inner observable. It's composing an outer observable with many inner observables, which end up getting flattened. Hence why it's called flatMap actually in other platforms, right? So this inner observable is the duration for the point event that was used to project it. Okay. So we are actually attaching a duration now to this username, and what the duration is where the state lives, right? This is how we're being stateful in our query. It's like implicit, right? It's like this hidden state. You don't tend to think of it this way, but well, maybe you don't. I don't know. It seems people don't tend to think of it this way, but I try to force myself to because I like thinking of it as the observables capturing the state for us. And it's up to us to define how long that state lasts, right? What is the duration of that state? And that's the observable we're projecting it into. So we might say that when a user comes in, we want to connect, right? So you might say we want to project it into a connects query, right? And then in that case, when the connect is pressed, we're going to actually want the user still in scope, because then we're going to have to pass the user as a side effect to actually connect, right? Perform the connection on the server. So we can project the user as the output of the connects query. So now you're going to have an input. The input is like an observable of users, right? And each user is projected into an observable of users. But an observable of users is where the user is pushed out when the user wants to connect, when they click the connect button. And then the SelectMany operator, or flatMap and other platforms, flattens all of those inner observables into just another output iObservable of user. So it's iObservable of user in, iObservable of user out. And on the inside, we're creating a duration for each user that lasts the lifetime of the connects observable. Now, this query doesn't actually work based, what we actually want here is a little bit different than this. But I think this is just good as hopefully just to serve as an explanation for the basic concepts here, right, of sequential composition and attaching durations to point events and essentially where to think of the state, right? The state's living in this closure actually here, right? The closure right here is closing over the user variable, which is local outside of this scope, right? So the user comes in as a parameter here, and then we're closing over the user in this lambda, and that's capturing the state in this connects observable. Right. Okay, so this query doesn't really do what we want, though, because, well, let me just implement the query the way I think makes sense to me, and then we could maybe talk about the differences. Actually, in that case, I'll leave this here for a moment just in case we want to compare them. But so the way I would do this, though, is instead of using SelectMany, because it's not really, so remember, SelectMany is going to do a flat map. Like every user that comes in, we get another observable that subscribes to connects, and then it flattens all of them. But that's not really what we want. What we want is a query that deals with like the last valid username and the next click of the button. So the way I see this would be to have a switch query. So we would say from username and valid usernames, and we're going to project connects and capture the username here. Oh, it's not username anymore, right? It's user. So we're going to project the user. Now, this gives us an observable of user. Oops. An observable of user, excuse me, right? And this is just like I described, where now we have that shape of an outer observable and an inner observable. The inner observable, almost always, you could think of it as like a window or a duration, right, of a point event or something. But what we want to do in this case is we want to switch to whatever the latest observable is. This observable will last until the connect button is clicked. That's what we want, right? And when another observable gets pushed in, like in other words, another valid user comes in, then we want to switch to that query. So we're always going to capture the latest state and switch to the query that listens to the connect button with the latest state captured. So the way to do that is to use the switch operator. So the switch operator gives us an output of an iObservable of user. It essentially flattens the iObservable of user into an iObservable of user. And it does that by switching to the latest inner observable. So every time a new inner observable is pushed in, it subscribes to it and disposes of the subscription to the previous observable, right? So the essence of this query is actually very simple if you read it top down. Remember, previously we started by writing a SelectMany query that started with connects, right? It dealt with connects first. So it was like this, from user in, valid users, so on and so forth. And we've reversed it, so valid users goes in front of it. This is so that way we can capture the user, which is the latest user, so when the connect button is pressed, it will project the user instead of the unit that is irrelevant to us. And then if another valid user comes in, we're going to get another observable, and we're just going to switch to that one. We're always going to keep switching to whatever the latest state is for the latest valid user. Okay? That's why we had to reverse these two, because this gives us the username and scope for when the connect button is pressed. Okay, so hopefully that's clear. And the difference now between this query and this query is that the SelectMany was taking all of the user durations that were projected, these inner observables that were projected, and flattening them all and subscribing to all of them. But that's not what we want. When a new user comes in, we no longer want the previous captured user in that query. It's already too old. We want the latest user. So this switch query is a really common pattern that you'll see. It's especially useful, I find, in user interfaces for some reason, but it's very common. Okay, and it's a little strange because you have to, your intuition, especially when you write something like this, when the connect button is pressed and the username is valid. Well, if the username is coming from an observable somewhere, it's weird, but you have to remember that you're going to need to reverse the order in which you would normally have done a SelectMany query, and then it turns out it shouldn't even be a SelectMany query either, because you don't want to flatten all the inner observables. You want to project each observable and switch to the latest one, because that contains the latest captured state. So it's a fairly common pattern to do this. And I love this query. I love switch queries. I find them to be so simple and succinct. They're actually a little tricky to learn, I think, but once you learn them, they're really, really powerful. In 3 lines of code, we did something that, if you wanted to implement this without this, would be fairly complicated and a little spaghetti-ish, and you'd have multiple methods that you'd have to go find. And then if you wanted to do the same thing again, you wouldn't have a nice pattern like this that you could just implement where once you get used to the pattern, you notice it and you know exactly what it is. Instead, you'd have another field on another type somewhere else with another method. They'd all be the same pattern, but just duplicated. Duplicating code is one of the primary things that we were trying to avoid here, right? By writing succinct, simple, declarative code. Okay, so now we have our switch query, but it's not quite finished because we also want to have valid service URLs as part of this, right? So it's only when the last known valid user comes in and valid service URL, right? So we want the latest of each. Now, what's interesting is that they are able to vary independently, right? So we could have, let's say we enter a valid username and then we enter a valid service URL, but then we decide to change our mind and we enter a different service URL, also valid. Then we change our mind again. We haven't even clicked the connect button yet. We enter another one. We're going to want to keep reacting to the fact that we're changing that one side of it. It's lopsided. The user stays, but the service URL keeps changing, or vice versa. It could be either or. So they can vary independently, and we want to combine them in some way where we're taking the latest of either of them. Okay, so obviously this is Rx declarative. We want some wording, some operator that reads similar to the way I've just described it, combining the latest. And there's actually an operator called CombineLatest. So obviously that's not a coincidence. I described it in that way. You might have used different words than CombineLatest. That's the trick. Maybe you wouldn't have noticed that the CombineLatest operator actually exists because you came up with words that were also correct and equivalent and synonymous, but were just different. So you looked for operators with the words that you came up with and didn't find that operator. So there's a learning curve here, right? That's part of the downside. You have to learn the operators in RX. You'll have to experiment with them and learn them. But once you learn them, you could see, hopefully, at this point and throughout the series, it should be clearer and clearer that they are so powerful that it really saves you a lot of time, right? In the long run, after you learn this stuff, you'll just be saving a lot of time, a lot of effort to do things that would be previously really complicated, especially dealing with concurrency and asynchronous programming. We're getting a lot for free here in just a couple lines of code so far. So anyway, in the CombineLatest, there's various overloads of many operators in RX. I'm not going to look at all the overloads. We'll examine those as we need them. In this case, we just need a very simple, common overload of CombineLatest, which lets us combine two observables. Valid users combine latest with valid service URLs. Now, CombineLatest also requires us to project into an output because observables only have a single generic type argument, right? So you always have to have a single type that represents your data, a single data type. So CombineLatest doesn't require both of the input observables to have the same data type. They can be very different types, which is important, right? It's very useful to be able to take an observable of user and combine it with the latest values from an observable of URI. But then what is the output of our observable? It can only be one or the other, or some combination of the two, but it's up to us to figure that out. We have to define what the output type is now based on the two inputs. So CombineLatest requires us to pass in a function which takes in the left side, which is a user, and the right side, which is URL in our case, and project that into some other type. That will be the output of our query. We could call this input, input would be redundant now. We could call it state. We could call it user and URL, whatever you want. And it doesn't matter what type it is. Actually, sorry about that. That would be the name here. It doesn't matter what type it is. It could be a tuple. It could be a discrete type that you come up with yourself, whatever. In our case, I'm just going to use a tuple because I like tuples. And actually, it's fairly new. In C#7 now, we could use something called value tuples with a nice native syntax built into C#. So we're going to go ahead and use that. Let's install that NuGet package. And it likes that. So now we're projecting the input parameters. The valid user is the first parameter, the left side, and the valid service URLs is the right side. So that's a URL. And we're projecting it into a tuple. This is just tuple syntax in C# now. It's a struct called the value tuple, which just can contain any arbitrary state, and we can also name the properties in the tuple, which is really awesome as well. So we could say, instead of item 1, item 2, or whatever it generates dynamically for us, we could be it's not generated dynamically. That would be the names of the properties that are built into the value type in the NuGet package. But we could actually override those built-in names with names that are semantic, that we actually want. So in this case, it looks a little redundant here, but it works, right? The reason why this is important is because now we could say dot and we can get URL out or user out, right? So it's nice, a little bit more semantic. We want to keep our query readable, right? So that's important, I think. Now in our case, we could just project the user and URL. That's fine too. And our output is actually an iObservable of a tuple of user and URL, or URI rather, right? So that's the input for our actual call to the service at some point in the future. So when we actually perform the side effect of connecting to the service, we have our user and URL, and we know they're both valid. They both came from these valid input URLs, okay? So now when we read this query and compare it to the spec says when the connect button is pressed and the username is valid and the service URL is a valid URI, do some stuff. What we said is we could even be more specific here, from valid, let's call it valid state, from valid state in valid users, combine latest valid service URLs. This is similar to saying the and here, right? It's like username is valid and service URL is valid. Valid users combine latest valid service URLs. It reads similar to that. It's fairly close, right? And we're just projecting this is, again, just the necessary plumbing that we need to define for, I don't know if the plumbing's the right word, but the necessary mechanism that needs to occur just so that the compiler is happy and the query could continue with just a single type argument, right? But we don't have to read this as part of the spec. I mean, you get used to, when you learn the operators like this, you don't tend to read them as part of the spec unless they're doing some complicated stuff. It's fairly common to see something like this, where it's just, you're projecting into a tuple or a discrete type that just captures the state or something like that. But in our case, we could just ignore that part, I think. So this CombineLatest is just kind of like the and here, right, of the valid username and valid service URL. That we're calling that valid state. And from each valid state, we're going to select connects. Okay, so when the connect button is pressed, and then the select here doesn't really read as part of the spec either, but we know we need to have the valid state for the downstream processing. Obviously, there's going to be other rules that require it. So that is being mapped into the valid state that we need to use for the downstream processing. Okay, so it reads close to the spec for that reason. Now, you might argue that it's maybe not close enough for your taste. And again, this is not the only way to solve this problem, right? There's perhaps other ways to do it. I don't know that there's other ways to do it that are more succinct without maybe creating custom operators or something, or defining, taking these operators and just, or these this operation and wrapping it, or expression, that's what I was looking for, taking these expressions or sub-expressions and wrapping them in methods that read more like the spec. I tend to not try to go too crazy with that, right? It's not about making it exactly one for one. It's about the fact that when I go to maintain the app later, or you hire somebody else to come and maintain this app in the future, they're going to look at the spec and they're going to see, when the connect button is pressed and the username is valid and the service URL is a valid URI. Or it might just be implicit. You might not even have a written spec, right? This is just in their mind. And you might have somebody say, well, okay, we're also going to have some other input now, and we need you to make sure that's valid too, and that also is going to be a state that's going to be part of the side effect of connecting. And they're going to want to have to go to one place in the code where this exists, where this business rule is implemented. And it shouldn't be, it's a fairly simple business rule. It shouldn't be more complicated than 2 or 3 lines of code to begin with. That's usually your expectation. But then what ends up happening in reality for something like this is you have 3 different events and a field or 2 different fields, and it's not clear where to go to find this one business rule. Especially because of the fact that you don't have like a reactive program which deals with the problem as a model of streaming data and inputs and outputs and keeping everything nice and cohesive and together. Instead, you have to go find the class and the file that defines the class or the type that implements the rule, or at least partially implements the rule. You might have multiple types that implement this rule, and you have to find them all and figure out how they work together. This is just a much cleaner, easier way. And once you learn the pattern and get used to the pattern, it becomes really easy. You search for keywords in a file like this. When connect is pressed, you search for connect, and you find out here, this is where connects are pressed with the valid state. And you look above it and you say, we're getting the valid state from the valid users, CombineLatest, and with the valid service URLs. And we have to add another one. Let's see. There's another overload that lets us pass in another observable, source 3, for example, right? And then the function that we have to pass in takes the user, source 2 in our case, which is the URL, and source 3, and source 4, and however many more we need, and project them into a result. Right? So we can just keep adding them here. So maintaining this app is a piece of cake as well, right? We know, again, this is just a hypothetical example, perhaps a makeshift example, but the point is that for simple things, you would expect simple changes and simple implementations. And I can't see how you can get much simpler than this, okay? And like I said, you can go a little crazier maybe and start turning these expressions into methods and trying to do clever things like that to make it read more like the spec. I think that's probably going a little overboard, though. Once you do that, you end up making things a little bit too abstract, a little too hidden. The essence of the query, like a CombineLatest query, is so common that you shouldn't have to hide this. It should be good enough. It's already pretty abstract, right? We're already hiding a lot of unnecessary details, and it's a common operator. Once you learn the operator, you understand what this means on first glance rather quickly. You don't have to worry about trying to hide this at another higher level. Okay. Now, some code, some queries, as I'm sure we'll see in this app as well, can get pretty complicated, and those it might actually be worth creating higher level operators, combinators, operators that are implemented in terms of other operators, like we're doing here, to generalize certain patterns, or in some cases they might be very specific, just to hide some complex query that you don't really need to see most of the time to do your maintenance work. But the idea is, if it's queries all the way down, then that should be a fairly easy way to maintain things in your application, because you're dealing with a lot of complexity in a very succinct way. Okay, so that would be this query here, and then let's take a look at the side effects that let's see what would have to happen after this. So once we get the output of this query, which is to say valid state, with the implicit knowledge that the user actually wants to connect at this point, right? Because they clicked the connect button. We want to perform a side effect in the presentation layer, right? Disable the connect button. I don't know that we want to disable the connect button as a side effect of this query, because we could just make it where it's actually safer generally in UI development anyway. You disable the connect button right away because you're on the UI thread, right? So it's thread safe, and then you enable it again if there's some failure. And we have failure as orthogonal observables. So the user interface is clearly going to, or the presentation layer rather, is going to be subscribing to these observables anyway. It will know when it's time to re-enable the connect button if these fail or some other observables fail, right? So that might be a completely different query using these observables. These are like failure state observables or something, right? That's one way of doing it, or we might just do it, as output of this query. I'm not sure yet. Again, that depends on our needs at the moment that we're implementing that in the presentation layer. I should also point something else out here, which is the fact that I'm starting on the inside and sort of building from the inside out, or actually rather designing from the inside out, is not the way I'd normally recommend to build any program. You should really design from the outside in, right? Because we might be building the wrong thing here, right? We might start building implementing the interface and noticing that actually these queries aren't exactly the output or the interface, the input and output that the reactive program requires, and all of its contracts that we've defined might not actually be applicable, or they might be one off or something like that from what we really want. And that's why it's very important, obviously, to design from the outside in. I started here because this is really the guts of the program. It's the most interesting part, and it's also obviously the most important part for this video series, which is about reactive programming. So I didn't want to spend time building an interface first, but normally that's what I would do. You start from the outside and work your way in. From a design perspective, I tend to like to build from the inside out, though. So once you've designed the interfaces, you understand how things will work together, it makes sense to you from the outside in, then you could start actually implementing from the inside out. Because you want to start implementing as soon as possible, because that's where all the risk really is. You'll notice things about details about how to do things that you missed in the design phase. There's often a lot of details that you miss, right? Mock-ups are usually all you get from an interface point of view, a graphical interface point of view, and they almost always ignore all the behavior, which is the important part of an app most of the time. And building from the inside out will sort of reveal how to get the behavior, how to deal with state, how to deal with side effects. So it's important to get to this as quickly as you can. But I like to design from the outside in. All the contracts and interfaces, you go from the outside in, you step in. I think test-driven development sort of forces people to do that. I don't think you should do. I'm not a TDDer myself. I prefer not to do that. But I think that's one of the advantages of it that people like to say. I think you could get that advantage without TDD. You just start from the outside and design your way in. But in this case, the only reason why I didn't do that is, again, because this is the reactive program, and I wanted to start here. So it's okay, though. We'll find at some point when I start building the interface in the presentation layer that maybe some of these queries don't quite make exactly the sense that I hope they made, and we'll refactor. That's fine. Not a big deal for the sake of this video series. It's a learning experience then, so that's fine. But that means that for disabling the connect button, this rule here, I don't know exactly how we're going to implement it. So I'll just pick one now, and maybe it will be a bad decision later, but I'll pick something that's simple now. Disabling the connect button as a result of being notified that the service URL was invalid or the username is invalid means that I have to do no more work here. We're already done. We have that information exposed, so that's what I'm going to choose for now. The presentation layer will subscribe to these, and whenever these produce a value, it will know. It has to be stateful as well, right? It's going to have to know whether it's in the connected state or not, or check that or something. Then it will be able to determine whether or not the connect button should be in a stable state or an enabled state. It should have enough information to do that. So we're not going to worry about that here. And Q is a silly name. Let's call this, it's really connects. You know what we could do? We could actually be a little bit more succinct here. This is really our connects query, and this is our connects input. It's a little bit more explicit too, right? So we're projecting the input connections into the valid state and switching to that. Okay, yeah. And that's our connects query. Now, connects previously was an observable of unit. We're essentially changing it into an observable of a tuple of user and URI. It's like a projection. This query is like kind of projecting input connects into an observable that's enriched with data that we could use to actually perform the connection and the implicit knowledge that the user actually wants to connect at this point. When a notification arrives to an observer that's subscribed to the connects observable, it must connect, right? So that's taking the input connects and turning it into an output connects that would have to be, well, I don't know that it's exactly output yet, but it's something that's output at least locally. We'll have to subscribe to it in some way and cause a side effect, right? And let's see if there's any output that actually would be nice to represent. Connections. This is whether we're connected or not. Yeah, connection fails. We didn't even try to connect yet. And authentications is something else also. So we don't, so far according to the spec anyway, we don't actually have any, well, this is only the spec, the part of the spec that we looked at. But at some point, I would expect we'd want to know when connection was actually successful, right? Because we're going to disable the connect button as soon as, in the user interface, as soon as you press connect. It will be re-enabled if something's invalid or if there's a connection failure or something like that. But then we're also going to want to display a waiting animation and a cancel button, which again, we could probably just do right away. So we don't need this connects as an output yet for that either. Try connecting to the specified URL. That could be something that has to be done locally. And if the connection cannot be established or if the service URL is invalid, then we display any network error, service or URL validation errors. URL validation error, we've sort of moved already into this kind of thing here. Focus the service URL and select it. Enable the connect button. Yeah, so I don't see any reason to expose this as output yet. Yeah, we went up to here, I think, in our design previously, right? So we went pretty far ahead. The last part is change the connect button into a disconnect button and enable it. That's once we're actually successfully connected, which this observable does not represent. So I think this is just a local that we'll use to, you know, compose with other inputs or, you know, inputs from the service layer to figure out when we want to expose additional notifications to the presentation layer, like whether we're connected or not, and failures and authentications. All right, I can't think of a challenge to give you for this video, so I'm just going to leave it here, and thanks for watching.